Okay, yo. Going to look at now how to differentiate y equals a to the x. We've already met how to differentiate e to the x, and so how do we deal with differentiating y equals a to the x? Well, the first thing we're going to need to do is change the form a little bit and mess around with it. So if we've got y equals to a to the x, then a logarithm of both sides will give me that log y is equal to x log a. Jumped a bit there, taking a logarithm and then taking the power out in a oneer, but there is a bit of a transformation. Now, applying the exponential base to both of these things, e of log y is going to be y, and then we've got e to the power of x times ln a. Now, the beauty here is that now that we've changed the base to e, we can apply our chain rule that we know to find dy dx. So the chain rule for an e function, as you recall, basically says that we differentiate whatever's in the power and chug it on the front. Well, remembering that log a is just the log of whatever the base of our thing is, so just a number, we basically end up with ln a times e to the x ln a. With that said and done then, what can we do to neaten this up? Because there's a lot of things knocking about in here that maybe we could do something about. But what I'm going to do is I'm going to use the fact that when I've got a power of a power, I can times the powers, but I'm going to use that rule in reverse. The reason I'm going to do that is it means I can do e to the power of log a all to the power of x. And the beauty of that now is that I now have the log of a multiplied by, well, e of log a is just a, so I've now got a in there to the power of x. And so we can say, in general terms, the derivative of a to the power of x will be log a times a to the power of x. So if y were equal to 5 to the x, and why wouldn't it be? Y dash, the derivative, will be log 5 times 5 to the x, he says, squeezing it in.